So now that you've done that, let's look at what I did over here. So I chose tungsten, all right? Tungsten has many common isotopes. There are 5 that have at least a significant enough amount to put it into a percentage. So tungsten 180 is 0.12%, tungsten 182, 183, 184, and 186 all have significant amounts. Okay, 26, 14, 30, and 28% respectively. So when I'm calculating the average mass, I took all these numbers. 180 times, so why is it that I put 2 zeros in front of this number? Wilkes? Sophia? Who said it? Sophia? Right, it's a decimal, not a percentage. 0.12% really means 0.0012 of something, right? Just like 60% of something is actually just 0.6 something, right? So I converted that, yeah, you just add 2 zeros, right? So 180 times 0.0012, 182 times 0.2650, 183 times 0.1431, 184 times 0.3064, and 186 times 0.2843. Okay, and I added all those together, and I got an average of 183.89. Okay, if I look at our periodic table, 183.84. Okay, so pretty close. That is how that is done. Am I going to require you to do that a lot? No. But I do want you to understand how it works. Okay, I want you to understand that that is the process by which we establish the average atomic weight, or sometimes people call it the standard atomic weight. Okay? So we have all of these here. Well, what if you don't look up the isotopes? How can you understand anything about the average or the mass or the common isotopes by just looking at the mass? So let's look at vanadium. Okay, let's look at vanadium. Vanadium has a standard or average elemental mass of 50.942. What does this tell us about possible isotopes? So when we're doing this, it's easiest to just assume there are 2 common isotopes. More than likely there's more, but in many elements there's that's not a ridiculous assumption. So Repeat, what were you going to say? There's probably a lot of 51. Okay, so why did you think that there's probably a lot of vanadium 51? Yes, perfect. I couldn't have said it better myself. The closest whole number to this is 51. So if vanadium has 2 common isotopes, which is not always true, but we can kind of get an understanding that it is very likely that vanadium is oftentimes in the form of vanadium 51. Okay? So vanadium, let's look at the isotopes of vanadium 42, 51. 51 makes up, let's see here, nope. So vanadium 51 makes up 99%. So we were pretty dang close, right? That assumption that we made that there was probably a lot of vanadium 51 is the case, because its average is 50.942. Okay? How about zinc? Oh, zinc's a hard one. Let's go with nitrogen. Let's go with nitrogen. Let's see here. Sophia, what do you think the most common isotope of nitrogen would be? $14 or $15? Okay, I want you to be decisive. What do you think the most common one would be? 14? Why? Yeah. So the average is 14.007, meaning that the closest whole number is 14, right? So we see that nitrogen is very commonly probably going to have the common isotope is going to be nitrogen 14, which, let's see here, there it is, 99.63%. So you were right. And we made that assumption just based on the average atomic mass. Questions on atomic mass? Average atomic mass, average isotopes. Seems pretty straightforward. Yes? Okay. I'm going to leave it at that there then. That there then? That's a strange combination of words. Okay.